Welcome to Yaka Digital Network Videos. If you look at this photograph of a telecommunication mast, you see a towering structure packed with heavy equipment. Engineers calculate the exact heights of structures like this every day, and they do it from the ground, without ever climbing a single ladder. They rely on trigonometry. By tracing a virtual line from their position on the ground straight up to the top of the mast, they create a right-angled triangle. The specific geometric shape gives us a reliable way to map the exact relationship between angles and distances. To navigate these calculations, we use a reference tool known as SOHCAHTOA. This helps us connect a specific angle, let's call it theta, to the three sides of our triangle. The hypotenuse is always the longest, slanted side. The opposite side sits directly across from our angle theta, and the adjacent side runs right next to the angle, forming the base. Correctly naming these sides relative to your angle is the necessary starting point for choosing the correct formula in any calculation. Let's put this into practice. This diagram illustrates a 10-meter ladder leaning against a brick wall. The ladder makes a 60-degree angle with the ground. We need to find exactly how far up the wall this ladder reaches, which means we are solving for the opposite side. Looking at what we know, we have the hypotenuse, which is 10, and we need the opposite. That points us directly to the sine ratio, or the SOH in SOHCAHTOA. We set up our equation. Sine of 60 degrees equals the opposite side divided by 10. Before calculating, check your scientific calculator screen. Verify your device is set to degrees, indicated by a small d or deg. If you see RAD or an R, you are calculating in radians, and your final measurement will be entirely incorrect. With the calculator securely in degree mode, we multiply 10 by the sine of 60 degrees. The sine of 60 is roughly 0.866, giving us a final height of 8.66 meters up the wall. Using SOHCAHTOA allows you to convert a geometric layout into a single solvable equation that provides the exact physical length you need. Now let's look at a scenario where we know the distances, but we need to find the angle. This diagram maps a support wire attached to our telecommunication mast. The wire is anchored 5 meters from the base and attached 12 meters high. We need to find the angle at the base, our theta. We have the opposite side at 12 and the adjacent side at 5. This means we use the tangent ratio, the TOA. Tangent theta equals 12 divided by 5, which is 2.4. To isolate theta, we apply the inverse tangent function to 2.4. The calculator gives us an angle of 67.4 degrees. When mapping these calculations from word problems, accurately placing your angle is a common stumbling block. Look at this split-screen comparison. An angle of elevation is formed by looking straight ahead to establish a flat horizontal line and then tilting up. An angle of depression is formed by looking straight ahead along that same flat horizontal line and then tilting down. A strict geometric rule links these two. Because the horizontal line at the top and the horizontal line at the bottom are completely parallel, they form alternate interior angles. If you trace a geometric Z connecting them, you can see that the angle of depression from the top is exactly equal to the angle of elevation from the bottom. Every time you are asked to map an angle from a word problem, draw a perfectly flat horizontal reference line first. That ensures your angle is anchored exactly where it belongs. To handle word problems efficiently, use a 3-step visualization method. Sketch the triangle, select the correct ratio, and solve the equation. Try it with this scenario. A student whose eyes are 1.5 meters off the ground stands 10 meters away from a school flagpole. Looking up, they measure a 35-degree angle of elevation to the top. What is the total height of the flagpole? Pause the video here, grab a pen, run through the steps of sketch, select, and solve to test your understanding before we review the answer. Let's review the solution. Based on your sketch, you have the adjacent side of 10 meters, and you need the opposite side. Using the tangent ratio, you multiply 10 by the tangent of 35 degrees. This calculates out to 7 meters for the vertical side of your triangle. But your triangle doesn't start at the ground, it starts at the student's eye level. We must add that 1.5 meters back directly underneath our triangle. 7 plus 1.5 gives a total flagpole height of 8.5 meters. This summary graphic captures the core rules. Always anchor your sides correctly relative to theta, rely on the SOHCAHTO formulas, rigorously check your calculator for degree mode and use the 3-step visualization method to break down word problems. Trigonometry allows us to determine heights and distances that cannot be reached or measured by hand. You can watch more videos for all classes here and get all content at www.yaka.cc.